Last week in class, we looked at the idea of empirical formula versus molecular formula and talked about how an empirical formula is going to be your reduced down ratio, whereas a molecular formula is the actual formula that exists. So, for example, butane is C4H10. That would be our molecular formula. Something like C2H5 would be your empirical formula, since a 4 to 10 ratio would reduce down to a 2 to 5 ratio. What we're going to look at in this video is, what else can you do with this? How else can we determine an empirical formula besides just reducing down your molecular formula? So this is an example of a problem. It says if a compound is 80% carbon and 20% hydrogen, what is the empirical formula of the compound? Anytime you see percentages like this, they're going to be percentages based on mass, which means if it's 80% carbon, 80 grams out of every 100 grams are carbon. So we can say that we have 80 grams of carbon and 20 grams of hydrogen. Before we can go any further, we need to look at, well, what is a formula? And what we know is if we look at a chemical formula, let's take water as an example, which is H2O. Your H2O means that you have 2 moles of hydrogen for every 1 mole of oxygen. So when you write a formula, you're always talking about the mole ratio within that formula. So if we want to figure out a formula from the percentages or the grams that we're given, we need to convert that to moles. So to do that, we would need to look up the gram formula mass of carbon, which is 12. So if we take 80 grams of carbon times 1 mole over 12 grams, we get 6.66 moles of carbon. And you do the same thing for hydrogen. Hydrogen has a gram formula mass of 1 gram per mole. Grams go on the bottom so that they cancel out, giving us 20 moles of hydrogen. From here, we got to write it as a formula. We can't just write it as C6.66H20 because that's not how chemical formulas are written. Chemical formulas have to be written as whole number ratios, which that isn't. We also can't just round it to C7H20 because you're changing the formula. C6.66H20 is not the same as C7H20. So we can't just round it. So this doesn't work. So we need to find our whole number ratio. And the easiest way to do that is going to be to take whatever your smallest number of moles is, which in this case is 6.66, and divide everything by that number. When you do that, 6.66 divided by itself is 1. 20 divided by 6.66 is 3. That tells you that for every 1 mole of carbon, you would need 3 moles of hydrogen, or your formula would be CH3. If we look at another example similar to this, for the first problem here, it tells us the compound is found to contain 25.9 grams of nitrogen by mass and 71.1% oxygen by mass. What is the empirical formula? Again, percentages tell us our grams. So we have 25.9 grams of nitrogen and 71.1 grams of oxygen. To get to a formula, we need to convert to moles. So our gram formula mass for nitrogen is 1 mole for every 14 grams. And our gram formula mass for oxygen is 1 mole for every 16 grams. We do the math here. We get 1.85 moles of nitrogen and 4.63 moles of oxygen. Again, it doesn't work as a whole number ratio, so to find our whole number ratio, we're going to divide by the smallest, which is 1.85. When we do that, we get 1 to 2.5. We still don't have a whole number ratio, but we're close at this point. And to get this to a whole number ratio, what we need to do is take our 1 to 2.5 ratio, and you need to double it to turn it into a whole number ratio. So it's going to be N2O5. This last step here, sometimes you'll need to do it, sometimes you won't. Really depends on the problem. So if you get, a ratio that is 1 to something that's a half, you need to double it, just as kind of an extra step at the end. There's one more type of problem we're going to look at here, which is, well, how do we determine our molecular formula? So we can do that if we know the simplest ratio in a compound, or your empirical formula. You can also determine your molecular formula as long as you know your molecular mass. So in the problem here, it tells us the empirical formula is NO2, and it has a molar mass or a molecular mass of 92. What is the molecular formula to this? We can use this formula here, where N is equal to molecular mass divided by empirical mass. So N is going to tell us how many times we need to multiply our empirical formula to find our molecular formula. So if N is equal to our molecular mass, which they give us is 92 grams per mole, and we know our empirical formula is NO2, nitrogen is 14, oxygen is 16 times 2. When we add those together, we get 46. So if we do 92 divided by 46, you get 2. That tells you that your empirical formula of NO2 needs to get doubled. So if we double that formula, we get N2O4, which is going to be your answer. This part here always has to work out to be a whole number. If it doesn't, something went wrong in your setup, you really got to go back and fix it. Last example I want to look at here is kind of a combination of the two. So for the first practice problem here, it says a compound is known to be 54.5% carbon, 9.1% hydrogen, and 36.4% oxygen by mass. If it has a molecular mass of 88 grams per mole, what is the molecular formula? So to solve this, we know N is equal to molecular mass over your empirical mass. We know our molecular mass, that's 88, but we don't know our empirical mass. We also don't know our empirical formula, but we do know how to find that. So if we take our 54.5% of carbon, that tells us we have 54.5 grams of carbon. We have 9.1 grams of hydrogen. We have 36.4 grams of oxygen. So it's going to set up just like the first problems we looked at in the video. To get to a formula, we got to convert to moles. So for carbon, it's 1 mole per 12 grams. For hydrogen, it's 1 mole per 1 gram. For oxygen, it's 1 mole per 16 grams. For all of these grams go on the bottom, so that grams cancel out. When we do the math, we get 4.5 moles of carbon, 9.1 moles of hydrogen, and 2.275 moles of oxygen. To find our whole number ratio, everything's got to get divided by the smallest, which is 2.275. 4.5 divided by 2.275 is 2. 9.1 divided by 2.275 is 4. And 2.275 by itself is 1. That's going to give you your empirical formula, which is going to be C2H4O. If we find our empirical mass from this, so this would be your empirical formula. Carbon is 12, so 12 times 2 plus 4 times 1 plus 16 gives you an empirical mass of 44. So we know N is equal to our molecular mass, which is 88, divided by 44 is 2. That tells us this formula has to get doubled. So when we do that, we're going to end up with C4H8O2 is our answer, and that would be our empirical formula.